Welcome back to Arxflix. Today, we're exploring a fascinating new paper titled Towards Modular LLMs by Building and Reusing a Library of LoRAs. This research investigates if independently trained adapters can be reused to enhance performance on new tasks. Let's dive into how they propose building and reusing these adapters. To visualize this, here's an illustration that explains the concept. The study introduces a library of adapters using model-based clustering, MBC, and a novel zero-shot routing mechanism named Arrow. Let's break down the main methodologies and findings. Traditional approaches required joint training of routing mechanisms with the large language models, LLMs. This joint training is resource-intensive and not always feasible. The question this paper addresses is, can we create modular LLMs by first building and then reusing a library of adapters? The model-based clustering, MBC, technique clusters tasks based on the similarity of their adapter parameters, aiming to optimize transfer across multitask datasets. Here's how it works. MBC starts by training LoRa adapters on individual tasks, and then clusters these tasks based on the similarity of the LoRa weights. After clustering, they train one adapter per cluster, maintaining computational efficiency. This figure shows the positive correlation between the similarity of LoRa weights and the performance improvement when trained jointly. For the reuse of the library, the Arrow mechanism dynamically selects the most relevant adapters for new tasks without retraining. Arrow utilizes the SVD decomposition of each LoRa to generate a representation, routing hidden states per token and per layer to maximize variance. Here's a fundamental equation where W represents the weights of the base LLM, and B are the low-rank learnable parameters from LoRa. The researchers conducted experiments using multiple LLMs, such as Fight and Mistral. They tested on held-out tasks to validate their approach. The results were convincing. MBC-based adapters and Arrow routing provided superior generalization to new tasks compared to traditional methods. For zero-shot scenarios, they used tasks like Arc, MBPP, and more for validation. This comparison showcases different routing methods for both private and MBC libraries. Arrow routing significantly improved performance, nearing Oracle-level routing in some cases. Key findings of the study include: 1. MBC clustering enhances multitask learning by efficiently grouping tasks based on parameter similarity. 2. Arrow routing effectively reuses adapters, offering robust zero-shot performance without access to the training data. 3. The modular approach enables building scalable and adaptable LLMs that can outperform traditional methods. This study presents promising advancements in modular LLMs, showcasing the potential for efficient and effective multitask and zero-shot learning through a library of reusable adapters. Future work could explore other adapter types and scaling to larger datasets. Thanks for joining us on this deep dive into Towards Modular LLMs by Building and Reusing a Library of LoRAs. Be sure to subscribe for more paper breakdowns on Arxflix. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.